Ladies and gentlemen, welcome to today's session. Today, our speaker is Dave Kleinatland from Huntress. Go ahead, Dave.
Thank you, Jason. I just wanted to, first of all, thank everybody for coming and hanging out with us to talk a little bit about some threat research stuff today. We're gonna nerd out a little bit on this Friday here, so I hope everyone's having an outstanding Friday and a great conference otherwise. So we'll dive into this a little bit. We thought this would be kind of fun. I definitely love doing these nerdy topics with everyone. So we're going to talk about threat research, kind of the flow of it, how it goes on our end. We'll talk about why these techniques that the attackers are using are effective and what they're attempting to evade when they perform these techniques in using their malware. I definitely have some time at the end planned for Q&A. So if you have any questions, definitely queue those up. I've got Katie from Huntress hanging out in the chat there. She's going to relay those over to me. So I guess first I'll start with a little bit about me. Before Huntress, I spent almost 7 years working in the MSP space as a director of technical services for an MSP, fighting the good fight on that front. Prior to that, IT director at a general contracting firm. And before that, just some of those IT service provider jobs before we were called MSPs. I was sitting down with a colleague the other day trying to figure out what we were called before we had a label. But we really couldn't figure it out. And then that time, some forensic work as well. I had 3 years. I was a certified computer examiner. Did some of the forensic side of stuff, evidence seizure and collection, processing, reporting. So a lot of fun stuff on that end. So without further ado here, we'll go ahead and get started. So, understanding the attacker here helps keep us informed of whether or not our defenses can even make a difference. If we understand what their next move is, we can hopefully be prepared to defend against it. And it's trying to understand what that next move is a very continual and learning process, just like everything in IT is. If you don't stay up to date on the latest technologies, the latest, the newest hardware that's coming out, the different things that are available to you, if you don't keep up with that, then you kind of fall behind. And security is no different. The attacker techniques and tactics change constantly. We see new stuff all the time. I was watching a SANS presentation by a threat researcher named Eric Gross, and he countered there's an old cliche of the attacker only has to find one way to get in while the defender has to defend everything. He countered that with the attacker must get everything right, while the defender really only has to find one part of the attack. Today we're going to start analyzing a sample that we came across a few weeks ago. And when I first saw it and got with the other folks that helped create some of this content, we felt it was pretty unique because it's a fairly complex sample, but it's written in JavaScript. And as a joke I like to use a lot is we all know no good things start with JavaScript, but the reason that it's helpful for education is it's a very high level language. So it's very human readable. It's fairly understandable, even if you're not like a rock star code wrangler. It's JavaScript's pretty easy to read in many of its forms. So we'll go ahead and dive into this a little bit more. So don't be this person, right? I want to start with this little bit of disclaimer. This isn't a how-to class per se, but we're definitely going to be discussing some research techniques. We're going to be peeking behind some doors that that can cause some trouble if you're not sure what's going on. I don't want to say don't try this at home, right? Because that's super, super boring. I don't want to be that person. I don't want to take that away. Plus, some of you are going to try it anyway. So if you want to learn, which is awesome, which is super awesome, you have to try. We definitely want to encourage people educating, learning, having a little fun, but you just need to be careful. Malware can be dangerous. If you're playing with malware, it could be something like ransomware. You could inadvertently let an attacker in, if you're using their malware and their command and control stuff is still up and running, that sort of stuff. So be careful what you're playing with. Just use some common sense and some easy ways to do that here, right? Is just protect yourself and be smart. Step one, research and learning. Or Google the crap out of it, because that's kind of how that's sort of the running joke in IT, right? Everyone just says you're the guy or gal who Googles everything to get it working. Some other things that I use, that we use when we're doing threat research is things like virtual machines. We have a VLAN, a virtual LAN, that kind of helps segment off whatever you're playing with, your malware network from any of your production stuff. If you have like a bench network and you want to do a separate physical network, I've actually done that before in some of the office environments and things like that. We would have a separate bench lab that was like a separate internet connection, or at least a separate external IP address from everything. VPN's really good. If you're playing with any malware that can call back to a command and control server or something, you don't want to reveal your actual IP. And hey, if all else fails, a really good backup strategy, right? I'm sure there's some vendors hanging around here that can certainly help you with that. Tools here that I use in this presentation, you don't need a bunch of fancy tools to learn. You don't have to go out and buy a bunch of crazy stuff to start learning. Everything that I have listed here is free other than the VPN. So the first thing I say, pretty text editor. The feature you're looking for is context highlighting. And what that does is it helps, if you're not familiar with any of the coding side of things, it helps highlight words used in the programming language to make them stand out, to make things a bit more organized. We'll start to see why that's important in a little while when you start looking at a giant wall of code. If it was all just black and white text or yellow and gray text or whatever, you kind of go mad looking for it. So two really good examples there is VS Code. Visual Studio Code is free. It's a Microsoft thing. It's available multi-platform, and Notepad++ as well. Very popular. I'm sure there's probably a handful of folks here that actually already use one or both of those. You just need an internet browser. Preferably, one that has access to a JavaScript console. For this particular thing, we'll be using that. I'm using Firefox in this example, but you can use pretty much any of them. And virtual machines, very, very important. Really great feature is that snapshot feature on a virtual machine. So if you are setting up some malware and you're doing something and maybe it gets out of control and you nuke your virtual machine, you can super easy roll back, to that previous state and get things going. And then a VPN, that's the only thing in this list that you actually would have to pay for. Or I mean, you could probably set one up on your own, if you wanted to, as long as you were redirecting to some other IP address. But there are a ton of great services out there. If you're willing to commit to a year or two, $3-4 a month, I'm not talking super high level business great. I'm just talking about some random IP that's not yours. So some VPN service for that. And then, Google is ask Uncle Google, right? That's a really great tool that you can use when you're doing research. A lot of my daily education comes from just researching things on the internet. Another tidbit, if anybody here saw Kyle's live hacking demo yesterday, you can actually do all that with free tools as well. And we have information on that. Stop by our booth and ask how you can do the live hacking demo. We provide that as kind of a kit for folks who want to kind of wow. So today we're going to line everything up in kind of phrases of attacker techniques. So I presume at least some of you, if not all of you, have heard of the MITRE attack framework. The really, really short version is it's a list of known attacker behaviors, tactics, and techniques they use that's based on real world knowledge. And each category has subcategories, and it really breaks down things to how attacks can go. You can see the whole matrix of it, attack.mitre.org, M-I-T-R-E. And check that out. Some of the tactics that we're going to use, that we're going to talk about in this presentation, are listed here, and I'll go over them real quick. These are the most common ones you'll see. So obfuscation, real simple. We're going to encode things. We're going to make it hard to see. We're doing that to evade detection. C2, or command and control. I'll probably use that. Use those as the same. I'll say both, but C2 is just a server living somewhere else in the world, right? That's what the malware calls back to. That's where that particular server will send data back to the endpoints that they're controlling, or the devices that they have control of, and create, send commands to it to do things. So a lot of those they have to craft those in ways to avoid things like DNS protection or IP reputation filtering. You'll often see command and control servers in shared hosting space, things like an Azure or a Rackspace or a AWS, or any of those shared hosting platforms that you couldn't just blanketly block without causing a lot of problems. Persistence. So this is near and dear to us here at Huntress. This is what we do and love. The simple fact of persistence is, once I get in, I want to stay in. It takes some level of effort for me to, get out a phishing campaign, or send out a bunch of links or downloads, or drop a bunch of flash drives in a parking lot or whatever. So once I do that, I don't want to have to do that every day. If I had to make you click my spam email every day, I would be the most inefficient hacker in the world. So I will take that time, and once I'm in, I want to stay in. So I will craft something to make sure that I can stay in and keep going. Process discovery. So this is just, we're casing the joint, right? Like we're driving out and we're watching the front doors of the bank and seeing who goes in and who goes out, and when the money truck shows up and when it leaves. Like we're just trying to figure out what's going on. And when we do that, we start to learn things. If we learn what you have running on your endpoints, as an attacker, I know that maybe I have certain tools that work better against certain things that you may have in your stack. Or hey, maybe I get in and I see certain things in your stack and you're like, you know what, I don't want any part of this. Maybe that bank's got too many guards or some state-of-the-art system, or, too many controls in place. So I don't want to mess with that. So maybe they just bail and move on to the low-hanging fruit target. And file deletion. So that's the electronic equivalent of the old hiker's creed, leave no trace, right? When you're out there in nature, you leave no trace. They want to do that too. They want to remove as much of what they were doing when they leave. They're reducing that footprint. They don't want to know you're there, or at least if they do things like trash log files and whatnot, they're going to bail out, and like maybe you'll know someone was there, but you'll have no idea what they did. I guess that's probably second best, other than not knowing that I was there in the first place. So the way that this relates to the MITRE ATT&CK framework, I think for the home gamers here that are playing at home, each one of these things will map to an ID, a number. Everything in the MITRE ATT&CK framework breaks down to a specific category. And now, many tactics, which is like a general category, and techniques can be found in that matrix. The technique is a specific method. In the upcoming slides, in the bottom right-hand corner, you might see a little teal tag that has a phrase in it, and that phrase is going to be the name of the MITRE ATT&CK framework tactic or technique that's being described in that slide. I'm not going to get super nerdy and reference all these TA and T numbers today. No one's going to memorize all that, but you can search for those words in the framework. We're using the exact terminology that they're using there, so it's easy to kind of check that out later and match that up to something. And again, that site is attack.mitre.org for all that information. So we have to start somewhere, right? When data comes into Huntress, as you can imagine, we process, a ton of raw data that comes from the endpoints, but something has to make us look. We certainly have, our layers of automation and algorithms and our 11 herbs and spices that make Huntress Huntress, on top of our, rockstar humans behind keyboards getting the work done. But something triggers a look first. So this is a redacted kind of raw data survey of some information that we received about the attack that we're going to talk about today. And we'll take a look at that bottom entry there first. So that's a registry key that is an auto run. It's the user init npr logon script. And it's if you put a value in there, the computer will execute that upon logon. Excuse me. So an antivirus won't likely flag that the mere existence of that key is a problem, because it's a totally legit key. It can be used for legit purposes. Maybe you have something like a SIM or an EDR, something like that. Maybe that'll flag the creation of that key, because maybe it's not common, maybe it's something in your environment, is an auto starting item, but that might start contributing to alert fatigue, right? So the data that you see here in this value data column, the one above the bottom entry here, that's something that will need to be processed. So let's dive into what is going on here a little bit. So first, we're calling Regserve 32. That's a legit Windows binary. It's run all the time. It's used in normal operations of Windows. It's used a lot in software installation. It's for registering DLLs. Again, AV is not going to flag its use. EDR might be, it just depends on how aggressive you have some of your alert settings and stuff. Over to the right, we see a bunch of random numbers in .text. Now, to a human, that is immediately suspicious. Anybody in threat research or anybody, I mean, heck, working a help desk and taking those calls when customers come in and you see, we all know that random letters, numbers, and stuff is bad when it comes to malware. AMSI.dll is actually kind of a fun one. That's the name of a legit Windows Defender component. It stands for the anti-malware scan interface, and that's a part of Windows Defender. But as we'll learn as we go through this, that's not what we think it is. It's actually something the hacker brought with him. That's something else, but they're not going to call it like bad DLL dot whatever. They're going to call that something that, so they're hoping AMSI.dll will pass the brief sniff test. It won't set off any string matching alarms. It won't do anything crazy like that. But this technique, this specific technique, is called Squigglydoo, and we're going to talk about that a little bit. But it's trying to evade detection. Using these different names and whatnot is what keeps things from we don't want to call it the bad malware right away, because a simple string match might kick us out. The way that this appeared on the machine most likely is a user opened a mouse spam attachment. It was part of a phishing campaign, and that downloaded both of those files, that text file and the AMSI.dll. It downloaded that on the machine and then created this foothold via this registry key. So whenever this user logs in, this particular string of things is executed. So how do you start sorting through this stuff from a Huntress perspective, and from a lot of products? So most products will use their telemetry and statistics to approve their effectiveness. I'm sure everyone here has either checked or purposely unchecked the box that says click here to send usage statistics of this product. And what that is, that's just telemetry. Lots of products have it. Everything from antivirus to Microsoft Office, to even Tesla's autopilot. They take advantage of that fleet intelligence to continually improve their product. So at Huntress, we have the inside of roughly 500,000-ish endpoints, give or take, that we can ask for data. We can say, hey, have we seen this before? Do we see this being used in legitimate circumstances? But in this case, we searched on our backend and said, hey, show me this user init NPR logon script and everything that we've got going now. And we got a no results search. Which that sticks out right there, right? Like, we have all these endpoints, but this is not being used anywhere at the moment. We're not seeing this in play right now. So that's suspicious, because our fleet isn't reporting that it's being used. And some people, we were talking about this, someone asked, well, why don't we just flag it as bad, remove it if it's so rare, and then just move on? And the short answer is we can't just automatically flag something because it's rare. It could be good. This is a legit Windows method to do stuff, something you would do on purpose for real, like not a hacker would use this logon script key. So imagine if you had a security product or any product that nature that just nuked something because it was rare. And I'm sure everyone in the room right now is thinking about a client that has some super weird line of business app that they always have to fight because it has some auto starting component, and things like, anything that's watching all these things is causing some issues with it. So just because it's rare doesn't mean that we have to can it. And more importantly is just removing this registry key here, may not get all of it. We need to dig in a little bit deeper and see what's going on to get all the pieces of this puzzle. So everyone heard Squigglydoo earlier. Our end user ran that mouse spam payload, and it created the persistence using that Squigglydoo method. And I'm just pulling the crowd here. It's the best name technique ever, right? Like, we love saying Squigglydoo around here. We try to work it into everyday conversation. It's a name given to a technique specifically using Regserve 32 and a scrob scrobj.dll. It's down there in the bottom right. It's using those two techniques to run a scriptlet of the attacker's choosing. And in this case, a scriptlet is simply JavaScript or VB script wedged into some XML. And attackers learned when this technique was designed that, they could wedge this in there, use a combination of Regserve 32 and scrobdll. And it was very effective against bypassing the Windows App Locker feature that came around in Windows 10. It was really awesome at getting around that. So it was abused heavily when this was first discovered, mostly because it's using built-in operating system tools. Those are, even if you can't put Regserve 32 on a block list because it'll cause problems when doing a lot of other things in Windows. That last bullet point there is an example of what that technique looks like, but we are going to dig into that a little bit more here. So on the left-hand side, we have Regserve 32. It's for registering DLLs. It's very necessary for things like software installation, updates, general Windows operation. You've probably used that once or twice when you're going down some support article rabbit hole. You're on like page 4 of the Google search results. You're trying to dig deep, and you find some row of Regserve 32 commands to unregister and re-register some DLLs to get something working. Over on the right, scrobj.dll is a Microsoft script component runtime. It's part of the COM system. Some people may know it as DCOM. It was introduced in Windows around 93-ish. Just to get simply, without being too nerdy on what that is that component object model, or COM. It's just an interface for applications to talk to each other. And this DLL is the kind of middleman for that, to keep that, talking and moving. And that's how they're able to kind of inject scripts, because it's part of the scripting engine. Since both of these are valid and required components of Windows, attackers know they'll be present on just about every machine they encounter, unless something's kind of wrong with that machine or something special is going on. They know that when they get into a Windows box, those components are going to be available. And the first thing that they asked themselves was, how can we abuse this? So we're going to abuse that by kind of working in this little extra command, but here. We're not going to simply just register a DLL. We're going to add our own script as an argument. To that Regserve 32 to get our system to execute it. So in this example, the actual script is called mal.sct, and it's downloaded from evil.com. And then that gets executed on the endpoint. So I'm sure everyone's got creative things going in their mind right now. Like, where could that script come from? It doesn't have to be evil.com. They're like, I'll just block evil.com. Or Pastebin, maybe it'll be on Pastebin, which a lot of people are probably blocking these days, but it could be on Dropbox or OneDrive or any number of AWS or Azure or any of those hosted sites, any of those shared hosting platforms, things like that. That could be there. And then that gets a little bit trickier to block. Maybe you're in an environment like blocking Dropbox could be detrimental to a lot of folks. And that script can contain anything. But I've got a little proof of concept here that we can take a look at to see, just very simply how this technique works. So you can find this on the internet if you Google like Squigglydoo POC or something like that, which is a proof of concept. The original researcher, Casey Smith, goes by SubT. You can see it there in the green text. And it's just the colorful text is just a very small script showing how this method works. And all it really does is it uses some JavaScript here, WScript shell, to run calc.exe. And when they run that command here, the regserve 32, which is the command that we saw on the last slide, and we kind of pull this from this local web server, what we're going to do is we're going to download that script. Here it's a local web server, but just remember it could be Dropbox or anything like that. And then once we execute that script, it actually pops up calculator. So calc.exe could be easily ransomware.exe or malware.exe. So this is kind of a fun one to play with. It's a pretty easy one to kind of dip your toe in the water if you want to play with it. Now, this is an older technique. It's like, I think it's circa 2016 or so. So a lot of modern preventative tools will stop this. But if you want to play with it in a VM, you can disable, certain tools and get that working. But, we still see this and similar techniques that kind of built upon it in the wild. They bypass tools and this kind of stuff still comes across our board pretty often. This sort of abuse of trusted applications in this manner is definitely not uncommon. So let's dig into what was inside that 530 whatever .text file. That this is what was run. So this is the script that was run. This is just a part of it here on the screen. This is what was run when the Squigglydoo technique was used. This was the initial payload that was executed after the mouse spam attachment. And if anyone's looking at this code and they're like, I don't understand programming at all. But no one can read this. When you have code that's just random characters like that, that's just a telltale sign that there's definitely something shady going on. Unfortunately there's no tape measure that I can get out and say, yep, this code is random or not random. There's no reliable or systematic automated way to detect and say, yep, this code is random or not. This is definitely obfuscated code. Another thing that made it difficult is it was only about 11 lines when it was on disk. They tried to stretch the lines out as long as possible, but when we formatted it as JavaScript, it was well over 200. So that makes it a little bit easier to read when you expand that out. And if you have one of those prettier text editors, it'll help color this out to make it easier to read. So humans can see that this is bad very easily. No sane person would write code like this. If you tried to write code in this fashion, you'd probably end up balled up in a corner somewhere. So we can glance at it. We know it's up to no good. Again, that question comes up. Well, why don't we just mark it bad and move on? Mainly because we don't know what this does yet. We need to dig deeper and see what's going on. Maybe it'll help us get better detecting it if we dig any bit deeper. And at Huntress, it makes us write a better remediation plan if we have more of an idea of what's happening. Or maybe we're just nerds and we really, really want to know more. So this is a common authoring technique for malware. Experience and Googling kind of helps you identify some of these techniques. And when you see a string like this, all that yellow text is just very random text. When you see that stored in a variable like it is here in this JavaScript, the var command there, we know that that's some code obfuscation. It's almost certainly they've kind of rolled their own encoding. They'll be decoding it later. And the instructions to decode it are almost always, they have to be in the program unless they're pulling it down from somewhere on the internet. You'd have to put those pieces together. But more often than not, the instructions on decoding this are not far away from where this big blob comes up. This is definitely a marker that code is malicious. If you were doing this in the real world, you just make your app slower for no reason. So that deobfuscation method passes through 17 catch and try operations. And to simplify that down as much as possible, it's just math. Encoding and encryption at their very basis is all math. Each one's a mathematical operation. You can see them here, minus 887 plus 349 divided by 242. Each one of those little green numbers is just some math operation being performed as it steps through each phase of this. This is like the secret decoder ring in the Ovaltine box from the radio shows. And here's just a snippet of the few of the 17 that we saw. I'm definitely not Alan Turing. This isn't the Enigma. I don't want to do this much math. I just want the goods. I want this to spit out to me what it's going to do. And when you start looking through JavaScript, at the bottom of this operation, you can see I have commented out here. It's kind of in, I'll circle it here for you. And it's that function there, that DNE that's commented out, it's blue. We're just going to change that to console.log. And that's a JavaScript thing. It'll just spit out text of whatever that function's supposed to do. The DNE part, that function that's there before, is probably, hey, execute and run this payload. Like that's something that you start to see when you look at enough malware, that last function is always like, do the thing, do the shady stuff and make it happen. But JavaScript's super easy to tinker with. If you open up, your favorite web browser and you actually hit F12 on purpose, I know I hit it. I usually don't hit it on purpose. I hit it all the time, usually when I'm fat fingering something, usually a screenshot. But let's open up F12 on purpose and look for that console tab. This is the web browser console. If you're doing some sort of, website troubleshooting and stuff, you'd be really familiar with it, but it's not something that's super common in day-to-day life. But you can see that mess of code that's on the left-hand side. There's our random variable. We paste it all in there. And then right before I hit enter, I remember watching some presentation and someone had a slide about don't try this at home or whatever, but I'm gonna go ahead and hit enter anyway and see what happens. And I get code. I get more JavaScript code. And there's also a blurred out function there at the bottom. Some hackers are pretty rude, but we're going to go ahead and dig into this. So we promised a RAT. It stands for Remote Access Trojan, or Remote Access Tool, depending on who you ask. And this is our actual malware here. This is what the attacker was using to abuse this machine. We're still looking inside this 530.txt file. This was kind of phase one of this attack. The short version, this isn't the most interesting part, but we'll zip through it here. It snags this JSON.txt from this API whatever site. Please don't go to that site. It's a Russian language like swinger site or something now. And I'm really hoping the VPN service I use does not save logs like they claim they do. But you'll see that it stores, we read some stuff out of the registry here. That UN at the end is another function that the hacker wrote to just grab the username. So if we look at wscript.network and WN username, that's just looking for like the SAM account name for the technical folks, or the pre-Windows 2000 name of that account. We're going to be pulling that data. And then it saves it all into your app data folder, app data Microsoft. That's a common folder. That's a folder that most people aren't going to look in, but the user needs to have right access to. It's easily accessible. So that app data Microsoft folder is where they want to store it. And the registry key that was created was uniquely created for that user. You can see it was created under Software Microsoft Notepad and then that user's username. So it's created uniquely under that username. And it's it was created by that initial mouse spam attachment. When the user opened that attachment, it had to create a place to store all of its data. A couple of examples I saw from this one was like an efax, like, hey, your efax is attached, double click this, but it's like efax something.js, for JavaScript. Or another one was a macro enabled Word document. And why did they call it JSON.text? Some of the coder folks or whatever, they might understand that JSON is just a kind of, neat way to package data and process it. But this could have been living on a compromised web server. Like maybe the attacker doesn't even use their own web server to host their malware. Maybe they compromise a web server and drop the file on there. And then JSON.text might just pass the sniff test. So what did it download? More of the same, right? We've got our obfuscated code. We've got, the same kind of try catch sequence thing going on. So we did the same thing. We put it through console.log. We got some more readable JavaScript. And this time we got our full featured rat. We got everything that we needed to determine what this remote access tool was doing. Good code is easy and portable. It's portable and easy to configure, right? So there's some interesting variables here. If we look all the way at the top, we've got version control. The attacker wants to know what version of their remote access tool they've got running. Below that, we've got variables for command and control and payload download. And that's important for two reasons. One, let's say the attacker is getting kicked out of web servers pretty often. They don't want to have to rewrite a whole bunch of code. They just change a variable in it. Plus, this also smells like malware as a service, right? Like if I write a piece of malware that just has variables to change like where it's hidden, where it goes, then I can just sell that without these variables configured, maybe include some instructions and say, here's how you configure your new malware. Below that, we've just got some kind of housekeeping things, some timeouts, some error retry stuff, nothing crazy. There's a unique key in there, that RR key with the long string, that maybe that's an encryption key, maybe that's a password. And my favorite is all the way at the bottom, there's a variable called GTFO. It means what you think it means. And if you haven't figured that out yet, we'll talk about that when we get toward the end of this. But it's designed from the ground up here to be sold, portable, easy to configure. So that's a pretty good indicator of something here is awry. So when I said earlier that JavaScript was easy, even for non-coders, here's a pretty good example of that. Thankfully, the attacker just called this function delete file, so that's pretty easy to guess what it does. But if we read the two things in here, we have if file exists, then delete file, so they're even nice enough to just check and see if the file is there before we even try to delete it. There's also some other stuff, like detailed OS information, checking for internet connectivity, kind of just basic tools. But if we want to get into some of the more interesting things that it collects, including some of that operating system information and how they do it, they need to gather intelligence about the environment that you're in. So when we talked earlier about case in the joint, when I get into a machine, I need to understand where I'm at and what I can do to make my life easier while I'm there. So I start pulling information. We'll start in the upper left. That's processor architecture. Hey, are we 64 or 32-bit? What can I do here? If we go work our way down a little bit, we start looking for system process. Okay, we're going to be looking for what's kind of running on the machine. If we look over to the right, we have OS version is the name of a function. And under that top block there, it says comspec ver, VER. So I don't know if anyone's familiar with the version command, tells you what version of Windows very specifically down to the build number that you're running. So maybe that could help you figure out what vulnerabilities I'm going to go after. What if this is not a fully patched operating system, they'll know about it. And then below that, we're going to collect all the IP address information we can. We'll learn things about the subnet. We'll learn things about, maybe what DNS is being used. So we'll start to look at all that. This next list here is probably one of my favorite. So if anyone's here glancing at this list of stuff here, does anybody see anything they recognize or maybe even use? Is this the attacker's like top 30 list, right? So what would you do with this information? If you were trying to be a nefarious actor, what would you do with this list of information? So what they're doing is, obviously they're collecting intelligence about security products. They actually called the function CAV, for antivirus. And, the rest of the function, processes through this list and it looks for antivirus names and it matches it to friendly names based on their service names. So what we'll do here is just kind of take a brief look at two of these. I'm not picking on them specifically, but, this one here, MC Tray, is the service name, the process name of the McAfee Tray service. And the one below that, the SAB service, is related to Sophos. So if you look at how they're matching it up, they're saying, hey, take this v2 and match it to variable v2 and McAfee. So they're doing this to help report back to themselves that, hey, when you see MC tray, tell me that it's got McAfee. When you see SAV service, tell me that it's got Sophos. It's just sort of enumerating that. These friendly names are for humans. The process and service names are for computers and scripts. But in this case, the attacker still wanted to be able to get a friendly name back about what antivirus was, instead of having to remember what MC tray or SAV service belonged to. So this is another chunk of the antivirus function, the enumerate antivirus function, and how the attacker can search those processes. So at first, you can see they're using WMI, WMIC. You probably use it in some scripts. Your RMM uses it to gather information about the system. It just pulls information from that Windows management instrumentation. It's also super handy for intelligence gathering. And you can see here they plan to get that from the Win32 process list first. But if that doesn't work, they have a failback. They're going to also use our good old friend task list, which just gives us a nice big, a list of all the things running. And they're able to kind of append all that. The command there is just, we're dumping all of this to a file, and they're going to use that information. They're going to exfil that file to be able to pull through that process list. And then earlier they're checking, they kind of got it. This was earlier in this script here. They're asking WMI to say, hey, we're going to make the WMI request as the account the script is running as. That's what impersonate means. Like, just be me. Impersonate this user, run this call. And they're trying to make sure that they have the privileges to make WMI calls, to make sure they can use WMI. This isn't really an evasion technique, but it's good practice. This is good practice to be able to say, hey, if this doesn't work, let's have a failback. You got to have that backup plan. And this is a part that I felt was pretty interesting. The attacker needed a way to get this data, send and receive data from the script and get it back from them. So this upper thing here where you see get string between, they wrote themselves like a markup language, kind of like HTML or XML. How everything starts with like tag and then it ends with /tag. So in HTML and XML, you use the less than and greater than signs, but they were using braces here. They were using the brackets and braces to kind of fish out data in the way that they wanted it to get that back to them. So in the example below, we can see that they have commands like task type, task ID, the URL, and PE type. And PE type was actually very interesting to me because it got used, so it's portable executable type. And what that did is it allowed them to specify whether they were going to run an EXE or a DLL when they were executing stuff. But using their own markup language, they were able to create a string to parse data about this system. So this is actually what they exfiltrated when they were saying, hey, tell me more about this system. They said, all right, we've learned hardware ID. We've learned, what antivirus they're running, that protection flag there, the username, the computer name, and just some detailed version information, IP addresses on the machine, and the version of the actual RET. So this is likely going back to theirs, in some sort of database, and they're able to look. Maybe they have like some sort by fields, and they can say, hey, show me all the machines that are running with, we found a vulnerability for some antivirus today. Show me all the machines that I have under my control running that, and let me find a way to abuse that. So I thought that was pretty cool that they wrote their own markup language for pushing stuff through. So we had to cut this code up to fit it on the slide. If you Google more_eggs, exploit or malware, you'll learn more about it. So this was a component that the attacker used from, it's called the MoreEggs backdoor. But it seems that this attacker used it for this purpose, along with some other code of maybe his own, or maybe they just patched together 4 or 5 different malwares. But like any good software, you need a mechanism to perform updates, right? Maybe we're doing bug fixes to our malware. Maybe we want to add some functionality to the program. The attacker was able to send a command. So if you remember that URL command earlier, they're going to grab that URL, they're going to send a URL to the script and say, hey, here's where the new update is, go get it. And this actually required a password, URL and a password from the attacker, because I don't want some other shady person updating my shady software. I want to make sure that I'm the only one who can do that. The script is pretty simple. So here's our file exist and delete file part. We're saying, hey, we're going to do an update. If this file exists, let's go ahead and delete it. And then we're going to go ahead and get this. We're going to go ahead and get the new script off the internet. So if there's any Linux folks hanging around in here, you'll be familiar with wget. They just wrote their own kind of wget function to pull this out. And then finally, it reports back the status of whether this task was executed. So you can see they're using their own markup language. Right before that variable is set to 1. So if the task does work, we set that task executed variable to 1, and we tell ourselves that, yep, we were able to do it. So that was a pretty interesting way that they're tracking updates, whether they worked or not, and even if they have their own update mechanism. I thought it was pretty cool to have their own thing there. So my favorite one was everyone needs a good exit plan, right? This hacker was no exception. The last option that was available in the script was called GTFO, and that's get the F out. That's part of that leave no trace that we were talking about. This is the let's clean up, let's get out. We don't want anyone to know that we were here. So we read out of the registry here from where we have our data stored. And then we start to assemble, we delete that registry key, and we start to assemble the file names of the files that we left on disk, those unique local and unique remote that you see there, the ones that end in .text. Those were the two payloads. That was the downloader payload and the actual rat payload. They said, hey, let's check and see if these files are on disk, and then let's go ahead and delete it. Let's get out of there. So this one, unfortunately, well, I guess fortunately for us, wasn't able to get out in time before we were able to dissect it. But you have to start thinking about how many places was this attacker in, did their thing, and then left, and no one even knew they were there. There was nothing particularly in here that would fingerprint it as like, oh, I left things behind, unless maybe they transferred files and didn't delete them. So it was pretty interesting to see this one had its pieces left behind, so they weren't able to get out in time to cover this up. But this particular variant had some kind of limited intelligence based on it. There are, there's components of it being used in other malwares, but it looks like this was probably sort of some chewing gum and duct tape kind of slapped together version of it. So it was a fun journey. So what did all of this analysis get us, right? Like, we just went through all this. That was a lot of work. So from a Huntress perspective, I can say, at the top here, that foothold, that's what we initially saw. That was what automation saw. That's what auto runs would have collected. That's what would have been the fingerprint on disk that, hey, this thing has something going on with it. And we would have generated an incident report, kind of like the one you see below here, based on that. But just using that registry key, the only thing that we saw was that 1530.txt file and that amsi.dll, which, remember, was our renamed Squigglydoo DLL. They just kind of brought their own with them. And the analysis allowed us to provide a much more complete incident report. All of the items in red is what we gained from that analysis. We were actually able to identify that second payload, that one there in red that starts with A6A. We didn't see that from the registry key. That was actually only called from inside that heavily obfuscated script. And then we removed the user, we saw that username value that went all the way at the bottom. Remove the username. We wouldn't see that unless we kind of dug into that script. So that was a couple of interesting things. And before, we only would have seen it as some kind of downloader, some obfuscated downloader. Whereas once we dug into it, we were able to identify that, this was able to provide us, that this was an actual full JavaScript rat and not just some random downloader. So I hope that provides some insight as to why that was worth it. So to wrap things up here, and then we'll go in a little bit of Q&A, understanding and dissecting a threat like this helps us relate to whether our defenses play a role in keeping threats like the ones that we see in check. If something gets through and nothing flags it, or there's no automation or anything that sees it, but we go through it as humans and dig through it, and we're able to identify it, we learn how to be more effective with it. We also get to see the variety of techniques that attackers are using to evade various components of your security stack. In this particular one, we were using obfuscation to evade the real obvious things like string matching and hash matching. We were using maybe some shared hosting space or whatever to try to avoid DNS security and things like that. We're trying to go to a site that is already maybe not, I don't want to say reputable, but not listed as a bad site. So we start to see all these different attacks that folks are using, and we're able to maybe find better ways to combat around that. And ultimately, we do it to make Huntress better. We don't want to just, do the bare minimum, scan the thing, say, hey, that's bad, and move on. We definitely want to dig into it and provide the full picture to give, our customers a much more robust and clear remediation plan, and make sure we get all of it when we can. And then, it's all about, that telemetry and stuff that we talked about. We make things better, things get better for everybody all around. The second thing is, I'm sure everyone here has team members that want to seek out exposure to new challenges, to improve their skill set, right? So everybody wants to learn. At least I hope. That's my goal is to learn something new every day. So it's no secret that awesome security talent's hard to come by. And while there are things that need to get done, we've all got that day to day to make happen. But finding opportunities to help team members that may want to up their security game will help bring that knowledge back into your business, as well as offer some professional development opportunities for them. So that's a win-win for everybody. So investing in those education opportunities for your team, it pays dividends on the back end, right? They're happy and excited because they're learning some new stuff, they're playing with some neat tools, they're having a good time, and then that education comes back. It makes you a better provider, and then more often than not, like I talked about earlier, that investment can simply just be some time. You don't have to buy a lot of fancy stuff to kind of start looking into all this. There's a lot of tools available out there. There's tons of amazing content out there in the wild to learn from. You might be able to find some on the Huntress YouTube channel. Shameless plug there on that. But we've got a lot of good education content out there. But the internet as a whole has just tons and tons of awesome content. Really good ways to learn. And finally, it's no secret that we at Huntress believe threat intelligence should be shared. Obviously with the proper due diligence and reporting methods and things like that. But those of us who know us know that we're active in that security community, especially the MSP community. And we share what is learned, share what is learned amongst your peers. Push information even back to your security vendors. It helps them improve their products. Push information to, if you have any kind of, local things where, things may be, kind of hyper localized or something specifically going on. Like COVID is obviously a kind of a worldwide thing where that, we're starting to, we see phishing attacks and things like that geared for that. But if you have something on a local scale, it's good to share that intelligence too with the peers in your community so they can understand that they're being attacked. And this sharing helps promote great security hygiene from everyone, from all the way down to the end customer through the MSP and the vendors. That's something that we've been super big on promoting here at Huntress. Before I get into the questions, I wanted to say thanks to everybody for hanging out with me today and nerding out. We do have some time for Q&A, and if that kind of runs over a little bit after this, I'll be hanging out in the Huntress booth. So if anybody has some questions and wants to chat on that, I'll be there to hang out on that too. So I'll start with a few questions that we have. Let's see. Someone asked, how bad is this specific malware? It's pretty bad. It's a remote access tool, right? So in this case, the attacker would have had the ability to do whatever they wanted on the machine. Depending on how long that rat could have run on that machine, it could have been, days, weeks, months, whatever. Well, not this specific one. This one was found pretty quick, but if it was hanging out, they could run any command, exfiltrate any data they wanted, install any software. They could hang out a while, see what's being collected, see what's going on, take action on that. So that's a pretty fun one. Another one was, let's see here. If a lot of malware is not written in JavaScript, what is it often written in? So these days, I would say the thing that I see the most is higher level scripting style languages. So things like, if it's not JavaScript, think VB script or PowerShell. PowerShell is really popular now. It uses a lot of similar obfuscation techniques as we saw here. We start to see those like long, crazy variables with a bunch of text jammed in them. And it's so there's a lot of, actually, there's a really fun demo that we do of a fileless malware attack. It starts out with some JavaScript, hides some PowerShell, super shady way. Swing by our booth, reach out for a trial if you want to see that one. We do that one a lot for folks in that process. Another one. How does Huntress deal with ransomware attacks? Is there any rollback capabilities, protection from the system restore points? So as you know, we can get more details at the Huntress booth, but I'll go over that pretty quick here. Huntress, we're not a preventative solution. So what we're doing is we're looking for those persistence methods. So like when that attacker created, in this example, where that attacker created that registry key to be able to kind of get back in, download, and do their rat. We sometimes, we see malware as a byproduct of like what we do. Because a lot of ransomware doesn't auto start. Like some of them are hit and run, like let's say RDP brute force, run my ransomware and leave. But a lot of them aren't. A lot of them get on there through some through a conduit, right? Like Emotet, TrickBot, real common ones. If anybody's, if anybody's playing the home game, they've probably heard that one a lot. The attacker will drop one thing, they'll use that to then distribute their ransomware. We'll often see a lot of those conduits, the conduit to the malware itself, so the delivery method for the ransomware or whatever malware it is. So no, they asked about rollback capabilities, system restore points. That's not something that the Huntress product covers, but we are working on some stuff for earlier detection in ransomware. So like ransomware canary type stuff to start notifying folks when we see activity like that, some host lockdown, things like that. How do the hackers monetize their persistence presence besides ransomware? Ransomware is definitely the big one. It's a lot of it could be not ransom in the sense of another one, I guess, that's becoming more popular. Not ransom in the sense of like, hey, we're going to ransom your data and we won't decrypt it. It's that we've stolen your data, and if you don't pay us money, we're going to release it in the wild. So that's probably, if I had to guess, that'd probably be the next biggest thing to ransomware. Another way, it's probably not as popular now, but we used to see Bitcoin miners. That was a pretty we still see it occasionally, but Bitcoin miner was a good way for them to monetize their persistence, because that one is pretty harmless in a lot of cases, as they would say. They get it there installed, and their thing's just using idle computing power to mine Bitcoin, and hopefully not stealing data or anything like that. That was a lot. That was a lot more common when Bitcoin was, I don't know, $20,000 a coin or something of that nature. Now I don't think it's quite as valuable, but and I think that's probably why we saw a shift from Bitcoin miners being very popular to the ransomware. And then another way that they monetize it is they monetize it on their back end, where it's the attackers that write the malware end up actually selling the malware to other attackers. So there's a whole business model in there that that goes as far as like they have affiliate programs, and they have referral IDs and program codes, and if you don't perform well enough in their hacker malware environment, then you kind of get kicked out of the program. They don't let you they don't let you play with them anymore. But we have some interesting content for that on the YouTube. If you're interested in sort of the economics behind that ransomware or malware as a service, there's some pretty cool stuff to check out on there. Let's see another one here. Can't antivirus or an endpoint solution detect obfuscated malware? Sometimes, in a lot of cases, endpoint security, some of those endpoint security components rely on like signature-based detection mechanisms to discover that stuff. And since you can imagine no one writes that code randomly like that. They write the code, like a normal person would, with hopefully somewhat readable variables and a process you can follow. They just use an automated utility to randomize that code. They just use an automated utility to do that. So they can just easily make that change to something else. So literally that hash or that file, whatever, could change every time. In some others, endpoint solutions, there's dynamic or behavior-based detection, that behavioral-based AI, machine learning, that sort of stuff. They can help detect things like the malware obfuscation when the malware runs. But the ones that are, if it's still purely signature-based, it's not really going to be effective at all. But we know that those endpoint solutions aren't always foolproof, right? Like attackers are always finding ways to change their methods. We hear it all the time. We see it every day. It's not the attackers are going to keep knocking on the door as we always put it on. So that's why defense in depth. I know that's super cliche, and we hear that over and over and over again. But defense in depth is awesome. That layered defense approach is how we stop, because if we can remember, we were talking about before that as long, as a defender, as you only have to stop one part of that attack, only one point of that chain needs to be compromised, and you can usually take down the rest of it. So let's see, we got a couple more. How much work on Macs do we get? So at the moment, we are a Windows only agent. We do have a Mac agent on our roadmap. So that's coming. So stay tuned. I don't have any data on that now. I actually saw an art. I don't have it handy right now, but I saw an article the other day of someone doing some Mac persistence, and it was pretty interesting. If you want to know more on that, stop by I'll find that article, stop by the booth, reach out to me. I'll get that link to you. It was a pretty interesting read. should we disable PowerShell remote unless absolutely needed? That's I think that's only a question you can answer. It certainly would help if you actually just say, hey, don't run PowerShell at all, but you also have to understand, or PowerShell remotely at all, but you have to understand that there may be legitimate methods to do that. So there is a chance that you could, stop something from working that would normally be working. So definitely, before you make any changes to preventing Windows system components from running automatically, kind of trial that out, do a proof of concept or do a small rollout to people who are a bit more tolerant to having to jiggle the handle per se to get things working. So that's kind of a fun one there, but yeah, it's there is a way, everyone's talks about disabling lots of different things, and you can really lock things down, but then you start trading end user experience, end user behavior. When you start trading that stuff off, it's a delicate balance you have to weigh. That was something that I kind of fought with on the MSP side of things when I worked there. Is we want to provide excellent controls. I'm sure everyone here remembers the initial rollout of two-factor, right? Like when two-factor became a thing, everybody really wanted to push back on the inconvenience that two-factor caused. But now it's just sort of a must-do, must-have. So just kind of apply that same logic when you're talking about disabling things like remote PowerShell and whatnot. Let's see here. Does the Huntress agent try to quarantine if it finds something? What is its remediation process? So I'll take the second part first. We report incidents with full remediation instructions. So it's definitely something that is kind of what we really strive to is, me coming from an MSP definitely wanted to do everything that we can to not contribute to anything like alert fatigue, or we don't want to like send people a bunch of stuff that they have to sort out. So when you get an incident from Huntress, we're letting you know with a priority level, low, high, or critical. We say, hey, this is a piece of malware or an artifact or something we see on your machine. We give you a risk-based overview and say, hey, this is a low risk, this is a high risk, here's what you should do. And here are the remediation instructions. And so we actually we write those instructions in a manner that even, a junior analyst can do it. Even a help desk tech or an entry level analyst can follow these instructions. They're like, hey, delete the scheduled task, delete these files. So we'll send you that. We also have our assisted remediation platform. It's currently in beta. But any partners with us, reach out to us. If you don't have it yet, just shoot an email to your account rep or support@huntress.io. We'll get you signed up on that. New partners, just ask for it. Basically what happens is in that incident report, you've got a link to link to the incident in our end. You hit a button that says review remediation plan. It tells you what our agent wants to do. It says, hey, we want to delete these file services. If that's okay, you click the approve button. Our agent will carry that out for you. And does it try to quarantine if it finds something? At the moment, Huntress does not perform any kind of quarantines or lockdowns or whatever. Some host lockdown stuff is in our roadmap. Reach out to us to learn some more information about that. But yeah, that's something that in certain capacities and situations that's coming for us. Let's see here. See if I have any more. I'm trying to look through the questions here. All right. I don't think I have any more pending questions. This looks like we're just a couple of minutes, got a few minutes early, but yeah. Thanks for hanging out with us. I hope everybody learned something. That's our goal here. I really enjoy doing some of these more nerdy talks. Again, I'll be hanging out in the booth. I'll be hanging out in the booth if you want to chat and learn a little bit more. Yeah, awesome. I don't have anything else unless anybody's got anything for me.
Great session there, Dave. Appreciate that.
Thank you.
Just for all of our audience right now, if you want to head over to the main stage session, we've got Jocko Willink coming up after a little while. But by all means, please make your way over to the Huntress virtual booth and enjoy yourself.